So I'm going to share my screen now. If you can see my screen, just let me know. Can you see my screen now?
Yes.
Okay, good. So I think we stop here, right? Then I added this slide there. If it comes to this, we can come back to this and use this to explain. But if we didn't manage to get there, we'll see what we are going to do. So another point is I don't want to complicate things at this point. So that's going to make everything look like, okay, what are we doing right now? But let's try to take it one step at a time. And all those lies we've maybe mentioned before, then we try to like turn them to true, and based on our reasoning or based on our understanding at that point, then we understand why that was lies at first and why this has to be the true right now. So, but so proceeding now, let's go back to our class notes. So in today's class, we are going to like finish up with the data type and our reference data type. Let's see if it's going to make sense for us to treat it now, or maybe we treat it later. And after the data type, then we proceed to like, there's a very nice topic I also want us to cover, which is memory and storage in computer, how it works, maybe like more like the fundamentals aspect of it. We're going to touch about it. And so once we are done with memory and storage, then we proceed to like, how can we write all those data types we've been talking about in JavaScript? Like, how do we write them? What are the syntax behind them? What are the conventions behind how to write them in JavaScript? So those are the stuff we are going to cover today. So if we manage to have time, maybe we talk about this reference data type and try to like, if you remember in the last class, I mentioned like we have difference between primitive data type and reference data type, right? So which I didn't explain. So based on our understanding of memory, that is going to let us understand the difference between the primitive data type and reference data type. So we take it one step at a time and we see how far we can go. So let's try to finish up on the primitive data type we're talking about. So now moving on. So I want to believe we all understand what strings are, right?
Yes.
Okay. And I also want to believe you understand what numbers are, right? No? Yes?
Yes.
Okay, thank you. And also we understand what some people call it char, some people call it car, some people call it character. We understand what character is, right? And we also understand what booleans are, right? True or false.
Mm.
Okay, thank you. And I don't know if anyone managed to do this home assignments.
Yes.
Is anyone willing to maybe show us what you did?
Mine is written in a book, not on the computer.
In a book.
Mm.
Let's see. Anyone else then? Hello. So the problem on my side is I can't see anyone. So it's hard for me to know if maybe we are all following along or we are not following along, because if you observe, it seems everyone in videos is off. So at least even if you are not talking, if I can see your face, then I know, okay, maybe we all understand what I'm talking about, or we don't. Yeah, thank you. So anyone else wants to show us how they wrote their strings, how they wrote their numbers, and what they understand by Boolean, and anyone? Anyone?
I
Okay.
just sent the assignment.
Okay, yeah, good then. So, I'm
So
going to
if
say,
you want me to, I was supposed to type it on a computer, but I didn't do that. Can I
you can tell
read?
us then. Yeah, you can read it if you want.
Okay, for strings, you say we should write 5 strings.
Yeah.
And the first one I've written that putting it in quote. All of them are in quote.
Which of the code do you use?
Double quote.
Okay.
Double. But you told us you can as well use one quote.
Yeah. And what was the word you wrote?
That's what I want to say. You know,
Okay.
you said you taught us that strange is a combination of different characters,
Yeah.
letters, signs, symbols,
Yep.
whatever. So I did not. Then I want. My question was, should it be only word, like
So
word?
it
But
can
then
be
I did not write word.
okay. So
I
it
did
can
not
be
write
any.
any.
It can be anything, provided you put them in quotes.
So I put all of them in quote, and I've written the first one. I wrote 2S dollar sign.
Where's my
2S
dollar sign?
dollar sign.
Like this, right?
Two. Can you? Where are you typing? I can't find where. Yeah. Yes. Like that.
Okay. And I'm coming.
Yes.
Okay. And the second one.
I've written in quote 3GK. GK. Yes, in quote.
And the third one.
Third one in quote.
Yep.
4F. That sign, what do they call it? H with double slash in
H.
between.
Okay. Ash like this or which one?
Yes. The next one I've written in quote 5Y.
5Y.
I. 2.
Okay. And the last one.
The last one in quote 6. Z, capital Z.
Okay.
3-4. J, small J.
Okay.
Yes, in quote.
And these you attempted
numbers.
Yeah.
I've written. You say we should write 5 numbers.
Yeah.
I wrote 9, 8, 0, -1, -2.
Okay. And these.
I've written that Boolean is an operation carried out to test for true or false. Example. Example. We assign 0 to indicate false and 1 to indicate true.
Thank you. And 1 to indicate true. Yeah, thanks. I think though we are not great in any way, but that should be yeah. Yeah, thank you. I think that makes sense anyway. So the whole essence of this is also like force us to go through what we did in class and see if we really understand what we did. So I don't know if anyone wants to go again, or if you think we can proceed. Should we proceed? Okay.
Yes.
So on our list, the next data type for today is null. And so the best way to explain this is more like something is let me say, we can use another word like it's empty. So but let's look at it this way. So the best way to explain it is, let's say we trying to fill a form and that form says first name. And what is our first name? If we intentionally or purposely trying to tell this, like, okay, this, I know you asked me for first name, but right now, I don't want to tell you what my first name is. So what I want you to do for now is I want it to be what? Null for now. Like all these to be empty for now. It's not like I don't have the data for you, but I want you to take this to be empty for now because I'm coming back. I'm coming back to give you the right answer. I don't know if you understand that explanation, if that explanation makes sense. So the
Like
purpose,
leaving it empty without filling it.
so if let's look at this second one, then with this second one, we are going to understand both now. So for example, now let's say we have another field, another form now that says we should fill first name. In this instance, remember the first one, we tell it like, okay, I know you're asking me for first name, but I don't want to tell you what my first name is. So for now, I want to assume it to be null or empty. But in terms of undefined, I know you asked me for first name, but at this point, I don't want to give you any value. But in this instance, I'm not telling you to be empty. But in this instance, I'm just telling you to be what? Like, I don't want to give you any. I know this explanation might seem a little bit the same, but the best way for us to understand it is when we start using it, then we understand it much better. So what I would just want you to hold on at this point is this first name. In this instance, you have to write something called null there. You have to put this null there to tell it, okay, now I know you asked me for something, but I don't have the first name now. So I'm telling you to hold this null as the name for the first name at this point. But in the terms of first name for undefined, then we are not going to put anything there. Is it clear or a little bit not clear? Hello?
Okay, so you mean that in null,
Yeah?
we must write null there.
Mm-hmm.
Undefined, we leave it empty.
We leave it empty. So right now, it might seem a little bit like, what is the whole purpose of this? Like, what is the meaning of this? So by the time we go to the third aspect of our class today, which is how to really write auto syntax, then you understand why we come about this undefined and why we come about this null. So the only thing I just wanted to hold down here is for undefined, it's more like someone is asking for something and you are telling that person like, okay, forget about this, I'm going to tell you later. But at this point, don't put anything there. That's for undefined. Like you are not defining anything for that. For null, you are telling, I know you asked me for something at this point, but purposely right now, I want you to leave it. I want you to put the word null there. But what that null is doing is just trying to make it empty for now. What do you think? Do you think it's a little bit clearer now or still a little bit not? Hello?
Damilare, please, can you just go over it once more, please?
Okay, yeah.
Thank you.
Let's take a look at this now. For example, let's say someone is asking for our first name. But let me think of another good example. Okay, yeah, let's stick with this first name. Let's stick with this. Okay, let's change it to last name. Last name. So someone is asking for our last name, like we are trying to fill it form, and someone is trying to ask for our last name. In these two scenarios, one scenario is we have data type called null, and we have another one called undefined. So in this last name null scenario, you are trying to tell these things like, see, I know you asked me for my last name, but at this point, I'm a little bit busy. Or at this point, I just want to assume it to be what? Assume it to be null, assume it to be empty. Right? But in the instance of undefined, you are trying to tell it like, see, I know you asked me for my last name, but at this point, assume I don't have a last name. In this instance, not like you don't have a last name, but you just want to set it to like be empty for now. Don't worry, let it be empty. Both of them in English terms, it's more or less trying to explain the same thing. But once you start maybe writing code, we understand okay the difference between undefined and the difference between null. So the only point I can emphasize on here is most of the time when we are trying to say something is on null, we're just trying to tell it to be leave it empty for now. Then as time goes on, maybe I'm going to tell you the right word. It's so in this point, it's not like maybe it doesn't have any value for it. There's a value for it, but that value is just we said to be empty. Okay, let's use that as an example. So in this last name, someone is asking us for our last name. Normally, we are supposed to put our last name there to be, let's say this is the last name. But in this instance, I don't want to tell it my last name. I don't want to give it any value. Instead of me leaving it empty, instead of me leaving it like I don't want it to be anything, then I can just tell it, okay, don't assume it to be empty, but in the other sense, still assume it to be empty, but take this value, like I don't want it to be empty value, so I'm trying to give it this null value. But in this instance, I'm telling it like, okay, I know you're asking me for like a value, but at this point, I don't have any value for you. This instance, no value, and it's not going to take null. But in this instance, there's a value, but I want to take that value to be null. I don't know if that explanation makes sense now.
Yes, but just for clarity's sake.
Okay.
Is it good to write the null there?
Yeah.
And also, if you put null, does it still give you the value for that particular data?
So what this is talking about is, so by the time we get to like writing our JavaScript code, so you get to a point whereby we call something variable declaration. We declare a variable, and let's say we want to do something like this. Let's say we want to do sum of or let's say we want to do square. We want to do square, right? Or square of 2. At this point, we said we want to do square of 2, and we know that square of 2 is what? 2 raised to 2, right?
4.
Or 2 times 2, right? Which is going to give us 4. So let's say before we start, we want to store the result of this square of null. We want to store the result of this square of null inside square of null. By the time we start writing the code, we write a place we want to store it. Once we get to memory also, we understand it's much better. So we write this, like this should contain the result of square of 2. We want to put it there. But first, we can put it this way. We declare this variable and we are not putting any value to it, right? Because we don't know the square of 2 at this point, right? So next line, we are now trying to compute. Let's say we are trying to compute square of 2. And this is supposed to give us 4, right? So once we know the value, then we can now take this value and put it back here. Sorry, this should be 4. So the point is, at first, we declare a variable
Equal to not minus 4.
Sorry? Yeah.
2 times 2.
Yeah, it should be something like, I'm just trying to like do something like this. I don't want to use the equals to there.
Okay.
So the point is, we declare somewhere we want to store this result of square of 2. Once we get that result, we want to send it back to this place. So how this thing is going to, what differentiates this null and undefined here is, in this instance, if you write it this way, we are telling this thing like, at this point, we don't know what the result is going to be. Make it like we don't know, make it undefined. That's instance of undefined. So let me put it here. So if you ask your JavaScript at this point, like we have something you can use to ask JavaScript, they call it console.log, but don't worry about all these terms now. We are still coming down to there. So if you write console.log, so what this one is trying to do is ask your JavaScript is going to ask like, what is the value we save inside of result of 2, result square of 2? At this point, it's going to tell you it's undefined, because we haven't set it to be any value yet. No value yet, right? So in the case of this is going to tell us undefined. And in the case of null, we can do it this way. Instead of making it no value, then we can write null there. So this is going to tell us like the only problem is we have a value for it, but the value is not the right value we need at this point. I don't know if that explanation still makes further sense now. So in this instance, null doesn't mean it's empty actually, but it's just trying to tell us like we don't really have the right value for it, but we want to take the value of null. But in the instance of undefined, it means there's no value there. And null is more or less like empty. Because we are trying to tell you like it's not like maybe we don't have value for it, but at this point we want it to be null, we want it to be empty. But in instance of undefined, we don't have the value for it, so there's no value defined for it.
So are you saying we should write no value, or we should just leave it empty?
So it depends on the case you are trying to use it. So if it is undefined case, it's good you put it this way. There's no value. So I'm just trying to put that no value there so you understand what is happening behind the hood. I don't know if that explanation makes sense now. Or you want me to explain it over again? Hello?
For examination purposes.
Sorry?
Yes.
Hello?
Yes.
I didn't get that.
Yes.
I should explain again, right? Or I should move on?
I explain, no, Damila, please.
Okay, so the point is, if I try to move to the last topic for today, the whole thing we are trying to learn today might be a little bit more complicated. But until we touch that last topic, then we understand this very well. But the only thing I wanted to hold right now is anytime we put null there, it's not like it's like we are telling it like we don't add the right value at this point, but I just don't want this thing to be no value at this point. So I wanted you to save the value of null, and null means empty itself. But we are not just telling it like this thing is no value, but just put the value of null there. And null means these things we don't have the value, it's empty. I know both of them might seem a little bit like the empty still mean on the it no value, right? But it's just like in English word, like normal English, we are trying to say, okay, first name. Instead of me telling them, okay, I don't have a first name, just tell it like ignore this to be empty for now. And in the case of this is the case of null. This is the case of null. And in the case of undefined, you ask me, okay, what is first name? So I'm just telling you, like, at this point, I don't have a first name. Like, set this, don't put anything there. This one is just trying to tell us, don't put anything there. But in this one, I have the right answer for you, but still, just set it to be empty so that maybe anybody doesn't come here and take that space. Or for example, let's look at this scenario. Let's say we have 2 chairs now. Let's say we are in a class. I think with this we should be able to understand. Let's say we have 2 chairs now. This is chair 1. How do you add one more cell?
Just right click and select and add cell or something.
Insert, okay, thank you. Insert below or above. So let's say this is chair 1, right? Let's say this is chair 2. And so let's assume this is a class. We have 500 chairs in this class. And in that class already, 498 people are in that class. So we have 2 chairs left empty. And we have 15 more people to come into that class. And the person 499 comes into the class and sits down here. So this is going to be person 499, and this seat is going to be for person 500, right? Once this class is filled up, we don't want anybody to come in again. And so with this, it means we have 30 more people outside that want to come in. And thank God, one way or the other, I don't know, maybe the school we all attended back in Nigeria for our bachelors, or maybe for, like the school I went to, it's more like the numbers of students are always more than the numbers of chairs or tables or the capacity of the classroom. So we have 30 more students sitting outside. And this instance, so the person sitting on chair 499 wants to go out and buy something. And if this person should leave, another person can come in, right? And take this place, which is going to be person 501, right? But if person 499 is so smart enough, he or she wants to go out, and he or she doesn't want another person to take that seat, what do you think that person can do? He can just put something there, maybe his or her books, and put it there like, oh, so someone is sitting here, or like I'm sitting here, please don't sit, right? But at this instance, it means nobody is sitting, but the person that's supposed to sit here already put something there, so that if person 501 comes in, if it's not the type of maybe a violent person or some person, is not going to sit there because someone is sitting there already, right? So if you look at it in terms of null and undefined, so it means at this point, this place, it's nobody's sitting there because it's someone that's supposed to sit there. In this instance, let's assume it's going to be like the books, I'm sitting, like that person is putting the book there, right? So in this instance, the right value that's supposed to be there is not there. This is explaining like the case scenario of null for us. Like the right person that's supposed to sit there is not sitting there, but I'm just putting book there. So that is the case of null. But in the case of undefined now, let's say person 501 felt like, okay, this class is so boring and I'm tired of this class, like I want to go home. Then he or she left the class, and that person didn't put anything there to signify that someone is sitting there. So what is happening here is this place is empty, right? Like no one is taking that seat. So which means either person 501 or person 502, whoever is very smart enough to see that this is empty is going to come in and do what? Take that place, because it is what? Nobody's taking it. So in this instance, if it is empty, that one is what? Undefined. I don't know if that explanation lets you understand it more, like very well right now.
Yes. Okay.
So still, I'm still going to stand on that note. This is more like a little bit lies also. We are going to understand the great truth behind it once we get to that third part for today's class. Do you think this is clear enough? Or is still a little bit not clear? Hello?
Just continue.
It's okay. Let's continue. Let's continue. Because
audience managed to get something out of it. That's the most important.
By the time we watch the video again,
okay.
It will be clear. Yes.
Okay. We should just continue at this point. Okay.
So continue.
So this last data type, even myself, I don't think I've ever used it. You can read what is there. Is a unique value that is not equal to any other value. So note, it's never really took off. So don't worry about it. So they don't really use this data type anymore. So which means we can skip it as well. But it's so good you know about it. Myself, I don't think I've ever used it before. So, but just be aware that you have this data type. So for now, you don't have to worry about it. At least if someone should come inside and ask us like, what do you understand about string? We can tell them something about string, even though it's going to be maybe one or two things we can tell them. If someone should come in and ask us, okay, what do you understand by numbers? We should be able to tell them one or two things. If they ask us what is character, we should be able to tell them one or two things. Same for Boolean, same for null, even though it's not that clear. And same for undefined also. Symbol, nothing at this point. You don't have to explain anything for them. Just tell them like, I don't have to worry about it. So now it's good that we understand, at least have a little bit understanding of these 6 type or 5 type of primitive data type. And you remember I mentioned we have the second data type called reference data type. And so for now, I won't go into like explaining them. I will only mention the 2 types we have for these. So by the time we explain memory, then we now come back to it, then we understand it much better. So the only 2 type of reference data type we have is they call it array, and the second one they call it objects. This is in JavaScript. And one thing I think I need to point out is if you go to any programming language, all these data type we mentioned, be it any other programming language, they also have them in other programming language. The only thing might be they call them different name, but it's more or less the same thing. The way we express them, it might be single quote. Some programming language might be so crazy that they want you to put it in double quote and not single quote for strings. But string is still string in. Go to Python, go to JavaScript, you have string. If you go to Java, also, if you go to other programming language, we have data type numbers. Though they might give it another name, but it's still the same thing. It's called number. And if you go to other programming language, character, I don't think so, because character is just something peculiar to JavaScript, and that's why we never. If you remember, we didn't list it as part of our data type, right? So I only use that to explain, so you understand we have something called character. And if you go to other programming language also, we have Boolean. It's true or false in other programming language also. Though they might call it other name, but it's still Boolean also. And also, if you go to other programming language, you have null, and we also have some other programming language might be crazy about undefined. Yes, but we still have a way we go about undefined also in other programming language. So let's see. And so if you go to other programming language also, we have something called reference data type. And the 2 type of reference data type we have is, for example, in JavaScript, it is called array. I'm going to tell you how they work also later on. And in JavaScript, it's called object. And if you go to Python, in Python, it's called dictionary. It's called dictionary, and they call it dic or dictionary. And in Python also, this is more or less equals to in Python, they call it list. So you can see like all these things, they are the same for more or less all programming languages. The only thing is they call them different names. Let me put it this way so it doesn't be complicated. So how they are being structured, how they are, I'm going to explain them later on. But I think it's good we understand something called how memory and storage works, so that I'm going to use that to explain the difference between this reference data type and the primitive data type. So if I go to the slide, let's see. So let's try to treat memory first. Once you treat memory, then we are going to come back to this, how to declare an initialized variable, and that's going to be our last part for today's class. So memory now, and according to what we understand in English, memory, storage, at least one way or the other, we are familiar with these both words. And in computer also, we have this something called memory and storage. Because come to think of it, if you have a mobile phone, someone send you a message or someone send you like an image on WhatsApp, then that image, if you allow it to download automatically, it's going to download and save on your phone, right? So come to think of it, how the difference between the storage and memory in terms of someone sending images to you on WhatsApp. So if that person send that image or images to you, if you choose to save it automatically, it's going to automatically download on your phone and maybe go directly to your image or whatever on your phone. And come to think of it, if you switch off your phone today and switch it on back, that image is still going to be on your phone. The only way it's going to leave is if you delete that image or those images, right? But in terms of, that's a very good explanation of storage. Storage, it's more like something, it's there for a long time until you decide like, okay, I don't want this thing anymore, and you delete it. But memory, it's just like something that saves temporarily on your phone. Do I have a very good explanation of maybe a very good real life scenario to explain that? Let me think. Okay, a very good scenario is if you're trying to like type something to someone on WhatsApp, and remember, if you copy something to your clipboard, on like you are trying to save something, or you copy and paste something, remember that whatever you copy is going to like save to something called clipboard, right? If you manage to switch off your phone and switch it on, that something on your clipboard is not going to be there anymore. I don't know if you've experienced something like this. For example, let's say I highlighted this part, then I press Ctrl C, right? Then if I go to, let's say if I come here, then I do Ctrl V, this thing, it's saved temporarily to like a memory. So if I switch off my computer right now and switch it back on, if I try to do Ctrl V, I'm not going to get it anymore, right? I don't know if you all agree with me on this. Hello?
Yes, if you did not save it before switching off your computer.
Yeah, exactly. Because once I copy it, it only saves to my clipboard. And if I paste it, I'm only taking it from my clipboard, copying it. So if I switch off my computer, that means it's the end of it. I can only find it if I save it on. So if I save it on my, let's say maybe Microsoft Word, save it somewhere on my computer. That's the only way I can access it. So in that both scenario, that temporary, more like a clipboard, that's how the memory works. And the other part is the storage. I don't know if that makes sense about the difference between storage and memory, but both of them, what they just do is more of saving things internally. The only problem is one can save on a long time and one can save on a short time. So now moving on. So, and it's very good we understand this memory or storage thing, but for the purpose of our class, the only thing we keep mentioning on is we keep mentioning something called memory, because what differentiates a very good software engineer and from someone that is not good is so what differentiates a very good software engineer and someone that is not that good is memory and storage. So what differentiates a very good software engineer and someone that is not that good is how to work with storage and data. So what did I mean by this is, for example, let's say we are trying to, so and remember I told you like for the moving on in this class, so the only thing we'll be talking about is memory, not storage. So let's say we have we are trying to save something on this, we are trying to process something, and remember when we did copy and paste the other time, right? And believe me, this thing we just copy and paste, though it's saved on clipboard, yeah, but it's taking some memory on our computer. So let's assume this is taking around, though this is not right, but I'm just assuming, let's say this is taking around, or let's say 200 kilobytes, right? So come to think of it, if you have millions of these, let's say you have millions of these, now multiply each one times the millions. Come to think of the size it's going to take on our computer. The size is going to be like 200 times what? Times that millions. Let's say 1 million or whatever million it is. You can see that's taking a very huge size on our computer, right? And so what now separates a very good software engineer from from someone that is not that good is, how can you save this thing on our computer without taking much memory? And that's where you know a very good software engineer and you know someone that is not that good. This same type of data, if you give it to like a very good software engineer, they know how to like manipulate their ways around it. Like it's not going to take much memory and it's going to take less memory. So like I was trying to say, so what differentiates a very good software engineer, very good software engineer, and the bad one, not bad anyway, but someone still learning, or let's say professional or whatever, professional, or let's say experience, and what is the English again? JJC, right? Or what?
JJC.
Yeah, JJC is it revolves around two things anyway. This memory or sometimes storage, but let's forget about storage at the moment, and the time. So let's say we are trying to, let's assume like we are trying to compute 2 times 2. We can assume like 2 times 2 is very straightforward, right? It's going to give us 4, right? So if we are trying to write a code to compute this, a very good experienced software engineer can write it in a way that is going to take less memory and is going to compute this thing very fast. A JJC is going to write it in a way, knowingly or unknowingly, that is going to take a lot of memory and it's going to be very slow. And all these things come at a cost. So let's go back to something and do something again. You remember the last website we visited was Airbnb, right? You can see like I press enter. You can see the time it's taking to load this thing. Come to think of it, all these images, they are taking some space, like they're taking space or size or some memory space on the computer that Airbnb, they are storing all their files or all their whatever they are storing. So think of how many images they have on this website. Think of all these strings, all these words, they're also taking memories. So come to think of it, the more images they have, it means the more space they are going to consume. And it means the more money they have to spend on doing what? Spend on providing facilities to cater, like to meet up this memory, to meet up with this memory demand, right? And also, I don't know if you get a big picture of what I'm trying to say right now. So the same thing also goes for the time also. If you load up a website, the more you can structure a website very well, the more it's going to determine the time it's going to like load also. So a very experienced engineer know how to like go around storing this thing so that it doesn't take much space and it takes time to load also. Whereby a JJC might not know how to figure this out, like, okay, how can I write this thing that's going to take less space and also consume less time to run? And the reason why I'm taking my time to explain this is so that going on forward, you also have to start thinking like as an experienced software engineer, so that you know how to like compute things so it doesn't take much space. Though this class is not for that. Even myself, I'm still like in this range, in this category also, category of JJC. You understand? So, but the point I'm just trying to make here is so you are aware of this and you know how to like structure things behind that. So now, moving forward now, so today we are going to look into this memory, but we are not going to look into time. Like it's another topic on its own when it comes to programming. So now, to explain memory now, or any questions so far? Any question? Is it getting complicated?
I think we are flowing with your gist.
Okay, good. So now, let's see. Oh, okay, maybe I do it this way. Paste. I can't paste that value. Oh, fuck. Okay, yeah, let's do it this way. We have and what does memory means when it comes to this computer thingy? So the something is we have this thing called memory, and let me delete one. Delete column, yes. Maybe delete one more. Delete column, yes. So and this is the memory space we have. And so for that memory space, let's say, you remember the other time, like this example we've been following, we asked first name, give what is your first name? And that person says, my first name is OYE, and it's, remember, it's a string, right? And so what we are trying to do is that person puts my first name to be this value, right? And this is the value, which is of a value string. And what we're trying to do is we are trying to save that value to, we are trying to like attach that value or assign that value to this first name, right? Like I'm asking, what is your first name? Then you tell me your first name. So I'm going to say like, okay, this person's first name, this is the value for that person's first name. So on that person's first name, so what I want you to do is, I want you to take it and save it in this memory. And remember I told you like, memory is just there for like a short period, not for a long period. So that anytime if we need to know what that first name is again, we can just call that first name from this memory, and it's going to tell us what? It's going to tell us like that first name equals what? This. Do you understand that, or I should explain again? Hello.
So if we want to know the first name and we ask memory, what did you say then?
So this is the point I'm trying to make. For example, if I just keep telling computer like, if I just keep telling, okay, let's say something like this. Let's say hello. If I just keep telling computer hello, hello, hello. I keep telling, right? I keep writing hello, right? And think of it this way. Let's say I only write hello once, and let's say at a point I need hello again, right? I also need at a point I need hello again. Or let me pick that case scenario. Let me use that case scenario of that classroom again. Classroom. We have 500 students, right? Or okay, I think I mentioned 515 students, right? That needs to come into that class. Good. So, and we want to do something like anytime the student anytime any of the student comes in, let's say student one comes in, we want to say, hello, students. Hello, students. One. So when someone else comes in, when the next student comes in, we want to do what also? We want to do student one. Anytime student two, anytime any of the student comes in, let's say student two comes in now, we also want to greet. Wants to greet student two to be comes in, then we want to greet the student. Hello, students. Two, right? And also if the third student comes in, third student also want to do hello student what? Hello student three. Also,
I think it's great.
thank you. Great, yeah. And also same goes for what? Student four. Now, remember what I mentioned the other time? What separates an experience from a JJC is how they can manage this memory. Think of it this way. Every time student comes in, we keep saying, hello students one, hello student two, hello student three. You can see this hello, we keep repeating hello, right? Which it doesn't really make sense. Think of it. For example, and come to think of it, every time they comes in, let's assume we are trying to save this hello. We are trying to save every time they come in, we greet the students and we're trying to save this hello. You know, remember I told you like a temporary storage is happening here. We are trying to, every time we greet them, this thing is being copied and saved on clipboard. And we save it hello student one, hello student two. You can see like this is going to take a lot of memory because how this thing works is this is going to convert. Remember I told you in the first class, like the only language computer understand is 10000000, and hello at a point equivalent to not this exactly, but equivalent to something like 10000000. And that's the reason why if you go back to this point, though we might not be able to like explain it deep. So, and that's where this slide comes in. But the point is, I still don't want to make this thing complicated. So, for example, each character on your keyboard, they are equivalent to these binary numbers, 100, which is machine language. For example, B, if you look at this, capital B, capital letter B means 66. And all these things works is if you read it from the back, from the front here, which is from my right, if you read it down to my left, you can see how my mouse is moving. If you read down here, so it means, so the first letter or the first word here means 0, 2. So something, this is what I'm trying to explain. I think if I write it's going to make sense more. So think of it this way. If you write something like this, or let me put it inside a table. So let's say we have these, and right click, insert column, insert row below, and so let's say this is the binary.
You can put your cursor at the last one and just click enter. You keep
Okay, enter, right, like this.
The last
it's not working.
oh.
So but let's assume these are a binary number, or this is our letter or any word, and this is going to be like the equivalent binary number, right? And so let's pick B for now, and we know that looking at this slide, we know B equals what, 66, right? And how do we convert this async number to binary? Though this plus is not supposed to be that, but let's look at how we can convert this to binary number, which is going to be we know that B equals to 66. So anytime you press 66, anytime you press B on your computer, it means 66 in ASCII. And how can we convert this to binary number? So, and normally most binary numbers are written this way. It always starts from 1 like this. It goes a long way, but I'm going to stop on let's just take this. Let's take these out. Okay, let me put these up. Control Z, Control X. Yeah. So this is the binary number. It's 1 1 1 1 1, and on the first side, this means 0. This means 2. This means 4. This means 6. This means 8. Down. So the next one is going to be 16. Next one is going to be 32. Next one, I think I have to write it down so we understand.
Where are you getting these numbers from?
So it's more like so what we're trying to do right now is to see how to convert this binary number to this ASCII, like ASCII. So for example, remember I told you like, we have something called human language, and we have something called computer language. So we are trying to see how we can convert this B to binary numbers. So, so binary numbers, it's more like 1 1. You know, remember we told you like it's 1 0 1 0 1 0, and 1 means true, 0 means false, right?
False.
So you are going to understand how the 0 comes in now. So it goes along with like we have. Let me add more. Yeah, add more. I think it's going to be good if I add more here. No, this should be. Maybe I can add it anyway. Any trick to add more? To add more cell? Control C, Control. Okay, right click, insert column to the left. Yeah. So I'm going to rewrite this now. This is going to be 1 1 1 1 1 1 1, and this is going to be like I said, this is going to be 0. I think this is to be 1. I might not be 100% correct on this, but we can always confirm anyway. 4. I think maybe 8 or 6, or we can take check so we don't give false information now. Convert binary, convert X to binary. Table. No, is it not even X itself or convert yes. And it's becoming a little bit complicated or crazy at this point. Yeah. So this is it now. So this is going to be it should be hexadecimal 0 1 2 3. Yeah, so it should be 4. Maybe it should be 2 2. Yeah, 2. So, but the point is, I'm trying to like confirm the order. I think 2, 4, 8, yeah, 16. You can also cross-check this data anyway. 32, I think 64, and this should be 120, 128, down like that. So, for example, now we want to convert B to binary number. So the point we're trying to do here is to convert B to binary number. So let's try to like add a row below. So now B to binary number. So remember, how can we add all these things together to get, remember we said B is 66, right? And so we said the first one is 0. This means for the first cell, it means this one equivalent to 0, this one equivalent to 1, this one equivalent to 2, this one equivalent to 4. So which means if we want to get, let's say first time we want to get 2, maybe we can start with easy ones. Let's say we want to write 2, 66. Let's say we want to write 2 in binary number. Where does 2 falls in this? Where does 2 falls? Like where can we find 2 on this second row?
To my own right.
Yeah,
my
like
right is at the
so
third.
either you read it from this side or you read it from that. But most people read it from this other end, like where I put my mouse like this. So 2 falls on the third column, right? So and wherever we see that thing we are looking for, we put 1 there, and the rest is going to be what? 0, 0. And if you want also, you can set all these to be 0, 0, 0, 0 down. So this way you are telling computer like this is 2. This is very easy way to represent 2. Let's take another example. Insert below. Let's say also we want to write 6. And now this is a very good one. But on this spot, do we have 6 on the second row? No. How can we add 6 together?
By 4 and 2.
Exactly. Very true. Then we said that to be what? 1, 1. Then the rest is going to be what?
0, 0, 0.
Exactly. I don't know if everybody understands this. Does it make sense? Hello? Hello?
So
yeah, we are good.
if
Fire on my
for the
brother.
binary number.
So if everyone thinks you are following, so the point you're just trying to do here is to convert every of these letter these are all computer do it behind the wood, you don't know. So it's trying to convert everything you type. If you type my name is, so it's going to convert all those things to like binary number that the computer understand. Now going to 66 for example. Now we know that if you type, let's do one more thing before we go to here. Let me insert below. Yeah, so let's say we want to convert this 66 now. How can we get summation of 66 here?
We have 64. So we pick, then 64 is 1. Then 2 is 1
exactly again. Very smart. And this is going to be what?
0, 0.
So one quick thing we can also do is so if you send this to any computer, okay, we can also do a quick check now. We know this is what you can do a quick check and see if you are right. Remember I opened something the other time. Did I close it? No, it should be incoming. I opened this, right? So let's come here and yeah, let's convert this binary to think exa or test. So let's put the value there. It should be on the same line and see what we are going to get. We might be right or we might be wrong. Now convert. ASCII convert. How come this? This binary number or drop file. Okay, let's do this way again. Let's type our test and convert to binary number. That's what we get. Let's type capital B and convert. Is it something wrong compared to what we have? Let's go there and cross check. Let's just come here. Is it? Okay, I think it's we are wrong. So the only problem is going to be with this representation I put it, which I was trying to confirm. Either we don't have one should be there anyway. Either we don't have maybe 0 there. Yeah. How many zeros do we have? Yeah. So what I can see here is we don't have these. Like 0 is not there. Delete these 5, delete this column. So if you cross check these to what we have now, let's see, which is going to be 0, 0, then 1, then how many zeros now? You can see it's correct now.
So
the only thing we don't have there is we don't have 0 there. And that was part of what I was trying to confirm the other time for this. Like, how do we represent this in that? So you can see now we easily converted, like by ourselves, easily converted a normal English word to like a binary number that computer understand. You can also see we cross-check this by ourselves now and we got the same value, right? So the last thing I want us to do here is if we are trying to write small b, so let's go back to that slide and check the value for small b. And you have to note here, like capital B, like capital letters are different from what small letters. So you have to look for the value for small letters. So if you come so B now, you can see small b to be what?
Let me zoom this.
You can see where my mouse is.
98.
So 98. Yeah, 98. So if you come here now,
when I know vessel, like my own, I'm trying to zoom that box that has the number on the letters. This box that has the letters, so I can see where.
Can you see now? Can you see now? So not to waste time, I think we are almost out of time today anyway. And I don't know, but let's try to do this last one and see what we can do. So we know B to be 90, small b to be 98, right? So how can we get 98?
I thought it was 99.
I think C is 99. C is 99, small b is 98. 98. So how can we get 98 from this now?
It's on my calculation. Can we do minus? Then they do minus.
I don't understand what you mean by minus.
Like since we
okay, you want to subtract one from another one, right?
Yes, we now say this 128 minus something.
No, it doesn't work that way. So the only thing you have to work with is this one down. So you have to find a way to, this is 64, right? So what other values can we add to?
32. That's the 96 plus 2, 98.
Sorry, which one?
64.
64.
Then 32.
32, yeah.
And then 2.
2, yes. Exactly, yeah. Smart. Yes. And sorry. And the rest is going to be what?
0, 0, 0.
0, 0, 0. So if we also take this, let's go back again and see if it's going to work for us this time. Let's go back and also convert from our binary to test and put this there, but it has to be on the same line. Yes, 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 and convert to, this should be a sequence. Convert.
Maybe you should have a 0 in front, because I think
Okay.
the site requests to have a 0 in front.
Okay, yeah, you can see now. Thanks for that observation. You can see we got small b, right? So anytime you do something like that,
This site, this, see as I'm doing it as if I can touch it from my laptop.
sorry.
No, I was just touching the screen to scroll up.
Can
you please scroll up? Okay.
Do you need the link?
Yes.
Okay.
I think you can drop the link in our chat so that everybody will have it.
I can also send it to the WhatsApp group later, or if someone can send it that way. And we
Yeah.
are almost out of time, but let me try and finish up with this memory so we understand this memory. If you can wait, you can. If you think you can wait, you can try to wait, and let's see if we can round everything up by 8. So now that you understand how these conversions happen behind the hood, you can see the more there are these numbers. The point is, all these things are not just happening that way. The more you try to convert, let's even forget about converting at this point. Let's not go into time. So the only thing we are trying to go to is to try to understand is the memory aspect. Every time you try to write hello student, every time you try to write or let's say any string or number, anything. So JavaScript is going to convert it into what? It's going to convert it into, let's say this is B. Maybe I can start with that, B. It's going to convert it into X, the value of that, our binary number. Let's say this is capital B. It's going to convert it into capital B and save that. This should be, this is going to be here. And its equivalent value for capital B, like this strictly equals to capital B, right? And so the point is, now think of it like this way, with the explanation I was trying to do the other time. Let's say we have 515 students, and one student comes in, wants to let them hello student 1, hello student 2, hello student 3, hello student 4, hello student 5, hello student 6. Till if you keep saying hello, it becomes, you can see this hello is common to all of them, right? The only thing that is different is what student 1, student 2, or student name. So come to think of it, won't it be that? And if you keep writing this hello student 1, hello student 2, hello student 3, and we are trying to save hello student 1 in memory, hello student 2 in memory, hello student, you can see this, the more these string together, the more memory you are going to take, right? What if someone now may talk to the professor or whoever is in charge, like, okay, see your guy, why don't you do it this way? Instead of calling hello all the time, why don't you have a place? Why don't you have a placeholder or a place? You save that hello, and anytime student comes in, you only try to add that hello to that student with the student number, which could be 1.
But even student is common to all. It's only the numbers that are different.
That's another good point. You can also do it that way, like, okay, student is common to all. Why don't we also save hello and student together like this? Hello and student together like this. And anytime they comes in, we only add their number to it. I'm going to point out something here, but I'm going to point it out later. So I don't want to point it out now. So now, why don't we save hello student in memory? And we save it somewhere, and anytime we need hello student, we just call it and add it to what? The number of the student, right? So that the only thing we have to do with is 1, 2, 3, 4, 5, 6, 7, and we just take this from wherever we save it and do what? Add student to it. In JavaScript time or in programming language terms, they call it this plus. What this plus is doing here is not doing addition. They call it concat. We are coming to that, but let me just mention it now. So what this plus is doing here is called concat. And what concat means is concat. They call it concatenation anyway, concatenation. So what this concat is doing is trying to so they use concat in this instance, like we're trying to add 2 strings with other data type. Remember, I didn't say string now, I said other data type. And if you look at this example, We are trying to add a string to what?
A number.
A number. You remember the first question someone asked in today's class, like the example, we are trying to add what? A number and a what?
And a string.
And a string. Which I told you like we can't add strings. We can't add a string. We can't add different data type together. We can't add a string and a number together. But now you can see like I'm just like breaking my own lie now. Now we are adding what? A number with a
number.
With a string with a number. So how come that is not right anymore? So this is where JavaScript becomes more smart. JavaScript understand that, okay, this person is trying to add string and a number, which normally in normal terms, in math terms, it doesn't work. If it is Java is going to yell at you like, it's not possible. This is a data type error. Like this data type it's not possible to add them together. But JavaScript is so smart that it's going to like, there's this term they call cohese. I know these terms become getting much now. So it's going to like force this number to be what? It's going to force this number, it's going to turn this number to what? To a string. And it's going to give you a result of what? The point is, it's going to turn this, it should be like with a string. It's going to force that number to be what? To be a string. Instead of telling you, it's just trying to understand what this person is trying to do is, it's not right. Well, let me just assume I understand what he's trying to do. So let me try to cohese it together, like make it to be one. And how can I make it to be one? Either I retain that to be string or I retain it to be number. But in this instance, JavaScript reads things from the left. Like most programming language reads things from the left. It's going to ask, okay, let me take what is on my left and assume that's what that person is trying to do and merge it together to be what? To be of the same data type. But that is not where we are going today. So the point where we are going is this storage I mentioned the other time. Like, if we are trying to say this, not to repeat this hello student, now we try to create a placeholder for this hello student and take that hello student, more like we copy and paste. Remember when we copy and paste, I say we copy, it's going to save up somewhere, like something called clipboard. And that clipboard is more like a temporary memory storage. It's going to take that hello, it's more like we copy it and save it somewhere. So same thing is going to happen here. And that how that clipboard works here is they only give it clipboard. But what that clipboard is also doing is like a memory. So now coming back to this place again. So it's going to take that in again. It's going to take that hello student, save it somewhere in the memory. And now we save it somewhere in the memory, right? But one question you need to ask me now is, what if we need that? Remember we said every time a student comes in, we want to take that hello student and not attach it to the number of that student and read that student to be what? Hello student 1, hello student 2, right? So let's say student 1 now comes in. All these things we did it before the class starts. Now the professor is in class, student 1 comes in and we want to greet student 1 to be hello student 1, right? So now, you remember we said we save this in the memory. A good question might be, how do we get this thing out of memory? Like, so a good question might be, how do we know where we save it in memory and bring it back to where we need it? Do you understand the point I'm trying to make here? Like, I randomly save this in the memory. I can take it from this place, save it here. But how do I know where I save it in the memory? Do you see the point I'm trying to make? So a good way to know how to save it in the memory is, so we have something called address. So so when you mention memory in computer wise or anything wise, so it comes with two things. It comes with the space you are saving it in that memory. So this is going to be, I'm not going to call this memory anymore. This is going to be space. It's going to come with a space where you are saving it, or some people call it space or memory slot or whatever you are calling it. Now we are saving it here and we need to give it a particular address, and that address, not to complicate things. So I'm going to assume you can give it anything. So in the first instance, I'm going to mention address. In the second instance, I'm going to mention index. So the reason why I'm going to explain index is because going forward in this class, we'll be using index and forget about memory. But I just want you to understand that all these things work is, it has to do with address, not actually memory. But for us to understand it, we'll be talking about index more, because this index is like one of the very good thing we need to understand in programming, and it's not something bad, it's something very easy. Because once you understand this index, you can do a lot of things. You can do a lot of data manipulation. So, but I'm going to explain this address first. Once I explain this address, I'm going to come back to this index. But I think it would be nice if I try to separate them now. Let me separate them first. But they are more or less doing the same work there. I need one more below, insert one row below. So the point, remember we saved this in the space, right? And we need to give it like a name or an address that, let's assume this address is something like this, 64 like this. It can be anything, but the way computer represents it something like this. So not to make it complicated, because even me, I don't know how this works anyway at the point, but not to make it complicated, let's just give it like 133. No, let's do it this way. This is 1, 2, 3, 4, 5. So let's call it 1, 3, 3, 5. So what the computer is going to do is going to give it an address, right? And one last thing I need to point out here is also called placeholder. So I'm going to explain all these 4 things, and maybe we end it for today. And maybe in our next class, we continue with how to really do all those things. So first thing is, when you save things to a memory, you can't just save things to memory. Once you save it, one thing the computer is doing for you is, computer is going to add an address to it for you, so that anytime you need it, it's going to call, like, for example, now let's take, for example, let's say when you move to Sweden, you can't don't just move to Sweden and start living in maybe in the metro or under bridge or anywhere. We are staying in an apartment, and every individual, you are not just staying in an apartment. We all have a unique address that, for example, this one is staying at, let's say he or she is staying at Stockholm, and you're not just staying in Stockholm, you're living in the apartment. That apartment has a street name, it has an apartment number, and it also has a room number. With those 3 things, think of it again. You have a city name, you have a country name, a city name, city or town name, you have a street name, then you have your room number, building name, and you have your room number. So for example, to make it very unique to individual, what makes it unique to individual is their room number. So with their city name, the country they are, the city they are, their street the street they live in, and their room number or the apartment number, all those combination of all those 5 things makes that address. So for example, if you are trying to know who lives in this particular address, you can easily look it up and know, okay, this is the person living in that address. So think of it as same for this. For us to know who is living in this particular memory slot or space, we need to give it a unique address, so that anytime we need to know who is living there, all we need to do is just call this address, and it's going to tell us who is living there. Do you understand that, please? Do you understand that point now? Does that make sense? All we need is the reason why we need this address.
Yes.
So now moving forward, but for us, it's going to be so hard. I remember the scenario we have is, once the second student comes in, or once the first student comes in, we need to, this is what we need. We need to call this address, and it's going to tell, okay, this is what is in this address, right? In this memory slot. But think of this address comes something like this. But how is it possible for us to know these values, which is very hard for us to know? And this also is very hard for us. It could be anything. It could be even 40006, blah, blah, blah. It's going to be hard for us to know. And that's the reason why, so computer makes it so easy for us that it now gives us an option to give it a placeholder. And what that placeholder means, like, is asking us, okay, see, I know that the address might be so hard for you to memorize. So I'm going to give you one easy way. So I'm going to give you one last option, something called placeholder. Give it any name you want. Give it any name you want, so that anytime you need this, what is in that address, like whatever lives in that address, just give me that name you want. Once you give me that name, I know this is the address you are referring to, and I'm going to get you that value, right? So, and that now takes us back to this explanation of these grids. Remember, I put a placeholder here, so you can now give it any placeholder, like this is going to be what? Grids. So anytime we call on grids, anytime we can give it any placeholder we want. We can say, okay, this placeholder is going to be great. Anytime we tell computer, okay.
Double E.
I don't know why I keep writing great. Anyway. So anytime we tell, thank you for that. Anytime we tell computer, like, okay, give me something that is in that placeholder great, then it's going to know, okay, I know what this guy is talking about. I know what this guy or this lady is talking about. Okay, this person is asking me to do what? Tell him what I save in the address equivalent to the, like in the memory slot equivalent to this placeholder great. Then it's going to do what? It's going to give us what? It's going to give us this. So, and want to think, because if we try to like call it with this address, then it's going to be so complicated because we might not know this address. It comes in different, it could be like this. It's going to be hard for us to know it this way. So computer is giving us the instance of giving it a placeholder, so that with that placeholder, we can easily access whatever is in that memory slot or memory space. I don't know if that makes sense enough. Hello? Hello?
For me, it's like I'm beginning to diminishing return. Like,
sorry?
Oh, I said for me, my brain is beginning to do like a diminishing return, like okay for today.
Okay for okay. And is this same for everyone? Hello?
I think you can take the index so that we just wrap it up on the index.
Well, okay, so this is recorded anyway. You can always fall back to it, and maybe we refresh on this in our next class. So now how the index works is, so you remember we give it a placeholder, right? The index also works like, so index is trying to like index these things based on something called number, like on numbers. So it's going to be the first memory slot in the memory is going to give it index of 0. The second memory slot in the memory is going to give index of 1. The second memory slot index in the memory is going to give it 2, like that. 4, 5, 6, 7, depending on the memory slot we have. You understand? So think of it also, if the address is in this format, this also is going to be like, I know. This is going to be 1, 2, 3, and 4, like that. So with these options, with this index and placeholder option, we can easily access whatever is in our memory slot at each particular spot. Let's assume we have a number called 45 here, and we have a number called 67 here, and we have a number called 1 minus 100, and we have a string called like this, and we also have which other data type we've treated. We have a character called D here, so that if we need something that is saved in memory slot in index 7, we can easily, provided if we save it with a placeholder, we can easily call that placeholder. We will understand this much better when we get to the last part of this class. We can easily call this placeholder the equivalent placeholder the name we are giving this placeholder. Let's say this is called, we give it a placeholder name of number 7. You can easily call this placeholder name of number 7, and it's going to return D for character of D. Or we can easily call that index, and it's going to do what? Give us this. Also, same goes for this. If you call the index of 2, it's going to return the value we save here. So how this index works, we understand it very well in our maybe in the next 2 or 3 classes. And but the only thing I want us to pick out is to understand this memory very well. So once we understand this memory, it's going to make sense once we start looking into how we can actually save our data on our computer, how we can take those data out, try to like manipulate them. And remember when we started this, like we said, we pass data to computer, we process and manipulate it and get a desired result. So this part we are treating first is type of data we can pass into the computers. Once we pass this computer data to the computer, we can process it, and all these little things it's going to make the processing very much easier for us. I know today is becoming a little bit time, like, let me look at the time, it is 20:07. But if I don't know how clear this is enough, but I can also retake it in the next class. But for now, I think it would be nice if we call it a day, right?
Yes.
Yeah. So any
It
questions?
will actually be good if we can be keeping to our time.
Yeah.
I know you are really sacrificing so much for this. Yeah.
I think we put that into consideration anyway. Any question before we go? Any question?
But I observe the class is not full today. Like some people are missing.
It's so hard to tell why. Maybe I don't know, to be honest.
And
Any
some people have
question?
also disappeared. You know. Some people are, but that means so far for me, I think you've done well again today, as usual. But maybe when we go back to listen to the